Okay, here's some more problems from 4.6, and we again have our reciprocal functions. So we have now a little phase shift on these. Not too complicated, so it shouldn't be too bad. Here my period is still going to be pi over 2. I'm just shifted to the right pi. So let me draw my axis over here. Period's still 1, so I should be okay there, so I'll make that 1. And I'll try to do 2 full periods of these. Oh boy, this is going to be tricky. So my period's 2 pi divided by 4 is pi over 2. And I want 4 pi, but then I'm going to be shifted to the right another pi. 2 pi, 4 pi, 5 pi, so I need to go 5 pi. Boy. Let me make this 4 pi here. So I have to make this 2 pi. That's kind of our ruler postulate. Once you put a number down, then everything else is set. Once you have your 0 and a number. Hopefully you learn that in geometry, the ruler postulate. Once you have 0, you can put a 0 anywhere on the number line, and then you can put a positive number anywhere to the right of 0. Then after you do that, then the number line is pretty much set. Everything's relative. Okay? Alright, so that's what we got, and let's make this as 1. Make this negative 1. Make this y, make that x. I think we're ready to go. And let's put our sign here, and our sign we start on 0. But we're shifted. We're shifted pi to the right. So instead of starting 0, I start add pi. That's all. That's the only difference. In other words, I just move my 0. I just add my pi, so I'm starting here. And then everything's the same. Like that, like that, like that, like that, like that. Oops. Sorry about that. Forgot my subdivisions. Shame on me. Because my subdivisions are pi over 2, not pi. Yeah, drat. Put that there, that there, that there, that there. Alrighty. Okay, so that's what we got so far. So let me do it again, and I'll try to just scratch these out in my mind. So I'm going to start here. I'm going to go 1, 0, negative 1, 0, and there's 1 period. Shifted to the right pi. Okay. And then another one. Go 1, 0, negative 1, 0. There we go. Glad I caught that. Well, I know I was going to have 2 periods, so something looked funny. There you go. All right. So if that looks all right. Should have my white out. Okay. Well, that's okay, because that's going to be covered by my asymptotes. Lucky me. Okay. So let me put the asymptotes down, so whenever I have 0. Ah, there we go. And one more. Bring these down a little bit more. So there's your asymptotes. There's your 2 periods with a shift. It's shifted over. So instead of starting here, and if I want to show another, I could actually just show this starts like that, but that's fine. Just shift it over pi. I hope that's okay. I think that should be fine. And then we'll just go up like this. They just want 2 periods, so it doesn't matter. I mean, there we go. And I could show that basically this would continue down here like this if I want to show another little bit branch of it. that's with the shift, so sometimes they might want you to show something like that, so you could show it like this also. Okay, so there you have a pretty good, that's actually more. So depending on where you want to show, if you want to go like from there, there's 2 full periods, 1, 2, or like this, 1, 2. Okay, that's not too bad. And then 43, 2, so we got a period change of 2, and we got a shift to the left. And that definitely is going to take into consideration our axes. So it's just a shift of pi to the left. So let's take a look at this one, and we'll start down here. We'll draw my axis over here. So I want to go 4 pi. So I can start over here and make this 4 pi. I think it's going to work. So that'd be 4 pi. That'd be 2 pi. 1 pi. So this would be 1 period normally. 3 pi. And all the various little subdivisions we might use. Except now I'm going to shift this pi to the left, so I'm going to shift this over this side. Because this is pi to the left, minus pi. And I guess the period's 2, so I could, well, I want to be able to kind of show my, so I'll make this 1 and 2, -1, -2, y, there's my 0, and there's my x. Okay. All right, so, and it's positive 2. Let me double check that. Is that all right, positive 2? Yeah, we're good. Okay, so normally we would start, for our cosine, we would start here. Normally we start at 1, but then it's going to be 2. And then go like this. But instead of that, we're going to shift it over, so we're going to start over here. Okay, and then we'll follow our cosine pattern. Like that. Bring it back up. And then over here. And let's just double check this. Remember, the period of the cosine is 1 full cycle is 2 pi. So there's -1 pi, and there's a positive pi, so that adds to be 2 pi. So we're good. And then we'll do another. So this goes down here. I'll put that under there. 0, and then back up. So there you go. So there's your 1, 2 cycles, all right? And let's kind of do this the way we see it sometimes done. In other words, I'll just do that, only that. I'll put my asymptotes in, so every time I see a 0, I have an asymptote. Okay, and then if we graph it, this will touch up there at the tip of that little valley. It's got to be over here. So it's not too symmetrical. I kind of messed that up a little bit. Sorry, let's get this around, curve this around a little bit more here like this. Okay, so something like this. Sorry about that. That's kind of off-centered quite a bit. Okay, and then down over here. Some of you do really nice drawings, so And then we have to kind of get this, so we'll start this one here, and we'll go up like that. And then we'll start this one here, the same thing, and we'll come down to this. And this is sometimes the way you see them. They look kind of strange, but that's actually 2 full periods. Here we have half and a half, and then we have 1, 2, 3. So that makes 1, 2, 3, 4. So that's another way of seeing it done. Like I said, this wasn't very symmetrical. So this one's got to go a little bit more like that. Sorry about that. Okay, but you get the idea. All right. So I hope that helps, and good luck.